Lesson 6.2 is exponential models. In lesson 6.1, we dealt with our first introduction to exponential models, right? We worked with a little bit of how to set them up and learned about them. In lesson 6.2, we're going to look at some of the places you use exponential models. And one of our big focuses is interest, okay? Specifically, compound interest formula talks about exponential model. And we'll look at a few other, things along the way. You guys probably, let's see, do you remember you're using a simple interest formula? You would have used simple interest along the way. Do you remember that over the years? Where not what we're using today, but the simple interest formula you would have learned somewhere along the line is I equals PRT, if I recall correctly. Okay. So you would have used that. But today we're looking at compound interest. And compound interest, if you look, here's the setup for compound interest we're going to use. But it uses that exponential setup. And I gave you a little bit of a definition up here because I don't know do you guys know what interest is? Maybe? Yes? No?
No. It's like.
Got a thought?
No.
No? I thought he was going to share with us. Okay, so I'll read this definition, then I'll give some insight here. An exponential model that is used to calculate the value of an investment when interest is compounded. For instance, when interest is paid monthly, the interest earned after the first month becomes part of the new principal for the second month, and so on. Interest is earned on interest already earned. So interest, interest can work in two ways. It can help you or it can be something that you have to pay. Interest can be something, if you put money in a bank account that earns interest, you could earn money just by leaving your money sit in the bank account. Okay? So I have no idea what interest rates in bank accounts are right now. I know they're very low, but if you leave money, I know at our credit union, if you leave money just sitting in the savings, it earns a little bit of money each month. Okay? So I don't remember what that amount is or anything, but you earn a percent. Okay? What we're looking more at is, you buy a house. You buy a car. Okay, let's talk you buy a car, because that's where you guys more likely are, right? Okay. If you're going to, pay $20,000 for a car. Am I going too high? I don't know.
Pretty accurate.
If you spend $20,000 on a car, what happens if you don't have $20,000 in your pocket when you go to buy that car?
You gotta put a down payment. You gotta pay monthly on it.
Okay. You gotta pay monthly on it. Now,
That's what I do.
do they loan you that money for free?
No.
No. That's what the interest is, right? They don't loan you that money for free. That's what the interest is. Now, the idea of simple interest is just, you pay one set amount of interest, or you earn one set amount of interest, just over on this whole loan. More likely what happens is something called compound interest, where, the first month, I haven't paid my car loan on. So now they're going to charge me a set amount of interest. Okay? Then, that interest adds to my balance, right, of money I owe. So then the next month, what happens when they tack my interest on next month? Okay, now I've got a little bit more money added from the interest last month. And that's the idea of compound interest, is that they are, you're paying interest on top of the interest they already charged you. Okay, so that's a little bit of an idea, but the formula we're going to look at is this right here. Okay.
Perfect.
P. Anytime we're dealing with money, P is your principal. And principal amount of money in the case I just suggested would be $20,000, right? P is that amount of money that you are depositing, if it's your savings account, or borrowing if we're talking a loan. We could be going either way here, okay? R is an annual interest rate, so that's your percent, except anytime we put a percent in an equation, remember we always use the decimal form. This is an important one right here. N is the number of compounding periods per year. So are they finding that interest monthly? Are they finding it annually, quarterly, semi-annually? daily, how often are they finding that interest? Okay, that's what N is. And then, oh, I guess I didn't put T, but A is just the value of the account after T years. T, of course, being your time in years. Okay, so you may have seen this formula along the way somewhere, definitely, because I feel like I've taught it in middle school and algebra 1 over the years. So it's definitely something you've possibly seen, or maybe you haven't. But let's look at example A and see what we can do with it. Tamara invests $5,000 in an account that pays 4% annual interest. How much money will there be in the account after 3 years if the interest is compounded annually, semi-annually, quarterly, or monthly? Okay, so let's go through and identify some information. Tamara invests $5,000 in an account. What is that $5,000? That is your principal amount of money, so your P. Okay. What about the pays 4% annual interest? What is that 4%? It's my annual interest rate. It's R. Now, am I going to put 4% in my formula as is? No. Change it to decimal form. How do we change it to decimal form? 0.04. Move the decimal 2 places left or divide by 100. Yes? So 0.04. How much will be in the account after 3 years? 3 years is T value. And then realize we're going to do this problem 4 different times, aren't we?
Perfect.
Okay. So let's start with annually. Okay. And this whole idea of annually, semi-annually, quarterly, or monthly is all of us trying to figure out what N is. So annually. If something is done annually, how many times a year is that done? Once, right? So realize if they ask you for annually, you see that word annually a problem, N is 1 because you're compounding the interest once a year. So let's fill in our formula here. We're trying to find the amount, so we're going to say A equals P. What was my P value? 5,000 for the principal. And then the formula, it's 1 plus R over N, which R is 0.04. N in this particular problem is 1, so you don't even really have to put that 1, but, and then raised to the NT. N is 1 and T is 3. Okay. Depending on your calculator skills, you can maybe put that in your calculator right now. I would encourage you to maybe do like 1 step of cleanup. And that is, I would clean up what's in the parentheses and what's in my exponent. So 0.04 divided by 1 is going to be 0.04. What's 1 plus 0.04? 1.04. Raised to the, what's 1 times 3? 3. Now, depending on your calculator would depend how you proceed. Most of you can just enter this in your calculator all at once. I'm not going to say all of you can, because sometimes there are calculators where you can't do that. I know if you use the one of my type calculators, you can definitely just put it in there all at once. If you can't, what you've got to remember is that this is 5,000 times the 1.04 to the 3. And so you might need to do the exponent first and then multiply by the 5,000 later. So, for instance, I could put this in as 1.04 raised to the third. Do you guys know how to do exponents?
Oh, yeah.
For me, it is the caret key here. I call it a caret, that little arrow. Okay. Some of you may have the X to the Y or Y to the X type answer or type button. So if you don't know where your exponent button is, let me know. So you could do it like this, and then after that, just leave that on the screen and type 5,000. Did you get that answer?
I sure did.
If you didn't, you did something wrong. Okay. Now, in all honesty, if I was doing this problem, I would just type 5,000 times 1.04 raised to the third. I would put it all in the calculator at once. And you can do that just as easily. Okay? If you're not getting that, let's figure out what's going on with your calculator. Oops. Which really comes down to, let's figure out how you're how you're entering it. So, what is that answer? And what's my label? Dollars. $5,624.32. Okay. Keep in mind, guys, when we're dealing with money, I expect dollars and cents unless it says otherwise. Which I didn't pay attention to what Savas says about rounding, but most of the time they're going to go dollars and cents. Okay. Again, if you need calculator help, let me know. Let's get that taken care of now so you can practice it.
Oh wait, that's our final. Right.
That's your final answer for annually.
Right.
Okay. What about semi-annually? What's semi-annually mean?
Twice.
Twice a year, right? You could also see the word biannually. I feel like I sometimes see that. That's also twice a year. And so that means that my n value is 2. Does anything else change? No. Everything else is the same. So here we are looking at 5,000 times 1 plus 0.04 divided by 2 raised to the 2 times 3. Okay, do the math. And again, I personally would do some cleanup inside. What is 0.04 divided by 2? Half of 0.04 is going to be 0.02. Add that to 1. I'm going to have 1.02. Raised to the 2 times 3 is 6. For me, that's what I'm typing into my calculator. Okay. I'm typing in that 5,000 times 1.02 to the 6. Does your answer agree with my answer?
No. Yup.
Because you haven't done it yet? Is that why?
Yeah, ma'am.
Okay. What would you write your answer as here?
5,630.81.
Okay. $5,630.81?
Yes.
Okay. Sounds good. Okay. Moving along here. The next option was quarterly. How often is quarterly if something is done quarterly? 4 times a year, yes? 4 quarters in a dollar, quarterly, 4 times a year. So now n is 4. So every place n was 1 and then n was 2, now n is going to be 4. Okay, practice. So 5,000 times 1 plus 0.04. This time it's divided by 4 and raised to the 4 times 3. I just keep changing that n. 5,000. What's going in my parentheses here? 0.04 divided by 4, and then add the 1 on. 1.01 raised to the 12th. Did you get a number?
No.
Not yet.
3413.
What'd you say?
5634.13.
Yeah.
Okay. 5634.13.
Okay, $5,634.13.
13 cents go along with it. You just work guess. Actually, no, you can just smell guess.
Okay. And
2 gallons.
what if interest is compounded monthly? What does that mean?
You said 2 cents.
12 times a year.
2 cents does the job just fine.
So N is 12. So 5,000 times 1 plus 0.04 divided by 12 raised to the 12 times 3. Still 5,000 out front. In my parentheses, it's 1 point something. Now, does this one divide nicely?
No.
Okay, so this one we're going to have to talk about best ways to use the calculator to do this.
Yeah.
Because when you do that 0.04 divided by 12, 0.00333333, right? If I have that written down right. And then raised to 36. Here's the deal. If you round that too much, you're going to drastically affect your answer. Okay? So, I'm trying to think the best way to suggest you guys do this on your these calculators.
1.0.
Yeah. So if I do that 0.04 and divide it by 12, there's that 0.003333, right? Now, I can go ahead and add 1 to that, right? So now I have the 1.00333. What can I go ahead and do from there? Raise it to the power of 36. Like, so this way, my thing is, am I clearing this off my calculator? No, I'm just keeping it on my calculator. So I could go ahead here and say, okay, I'm going to raise this to the power of 36. Because if I just start typing, it's going to take whatever my last answer was, right? That's what ans is. Whatever my last answer is. And I get that. And then I can take that and multiply by 5,000.
5636.
Now, if you did it a different way, here's what I'm going to say. Is your answer going to match mine? Yes. Okay. So 5636.36. Okay. And here's what I will say. If you want to do 5,000 times 1.00, and you put a handful of 3's on there like that, and raise it to the power of 36, you should get an answer that rounds to be the same.
Oh, okay.
Okay? My only fear is if you guys say 1.003, something like that. Oops. Raise to 36. See, now I'm a penny off, or 2 pennies off. And that was me just using 1.003. I didn't use a bunch of 3's. And so that's where I want to tell you guys that you need to use, either use the exact value or use several 3's. Yeah.
What?
No.
No, what?
We're not going to throw whatever Landon threw to Layton. We're not going to now throw it to you.
I was showing him my hand.
Mm-hmm.
But where
You're lying to me now.
No, I'm not. I got
6.624633305 times 10 to the negative 90th power.
I'm going to suggest
I
you
don't-
type something in wrong because it's giving you a like scientific
I don't
definition
know.
answer.
Yeah.
So when you did that, did you ever then, after you got that, did you add the 1 to it? So you need to add the 1 to it. So you have the 1.00.
Why are you doing this?
Does that make sense?
You need.
Then do the 36. There we go. And then,
Yeah, I get this.
Yeah.
so yeah, don't forget that step of. Okay. We're figuring out ways to do this. And here's what I'm going to say. Is there one right way to do this?
I'm good. Yep, no, I got it. Yep.
Definitely not just one right way to do this. However, there are multiple right ways. There are also wrong ways.
Okay.
So I want you walking out of here to have a right way, which is why I required everyone to get a calculator, at least put it on the desk so you can at least be tempted to pick it up and use it. I hope you are picking it up and using it, right? Make the mistakes now as opposed to homework when you get frustrated. Okay, now, it doesn't ask, but what do you notice as we went along here?
It got bigger.
Got bigger a little bit, didn't it?
Yep.
Okay, each time, and in this case, this is Tamara investing money. So the more often the interest compounds, the more money she's going to earn. Okay, she started off with $5,000. Granted, it's not a whole lot of difference. $624, $630, $634, $636. But notice, the more it compounds, the more money she gets. If it was a higher interest rate, or if she left the money in there longer, the more money she would get. So, a little bit of money information there. Okay, let's look at B real quick, and then we'll go learn a different formula. This one I just want to compare. This is $3,000 is invested in an account that earns 3% annual interest compounded monthly. We're going to compare the value between 10 years versus 100 years and look at the difference. Now, with that in mind, what pieces of information can you identify here? Okay. My principal, my p-value is 3,000. What else do I know? Okay, R is 3%. What am I going to use that as? Okay. Move your decimal 2 places. 0.03. And what else do I know? Okay. 10 years is going to be our t value. What's compounded monthly tell me?
It is 12.
And it's 12, yes?
Wait a dog on that. Wait. Yeah, all right. No, I got you.
Are you good?
Yeah, got you. Yeah.
Okay, so fill it in. It's going to be equal to 3,000
Where's T at?
times 1 plus, and it's going to be R over N, so 0.03 divided by 12, raised to the NT, which is 12 times, in this first example, 10.
Good
Okay.
job. All right.
Practice with the calculator.
Well, look at that.
Okay, so this time when you do 0.03 divided by 12, it's 0.0025. Add that 1, it's 1.0025. This time we're raising to the 120th power. It is a big number. So what do we end up with here?
1,048.46.
Is he right? Now, right there, guys, notice my interest rate is actually lower than the previous problem, but notice leaving it for 10 years, they've earned $1,000. I know, leaving the money for 10 years, that's the difficult part, but now, change the details here, and now we're going to talk about 100 years. So that means my t value is 100 instead. And let's see the comparison. So 3,000 times 1.03 over 12. And actually, the only thing that changes is a 12 times 100, isn't it? I could have written down what I had for the inside from the last problem. Only thing that's changing, t only changes once in the problem, so 3,000 is 1.0025 raised to the 1,200. Big number.
Yeah, I got
I'll
you.
take the answer.
Landon's got it.
Like,
$60,031.45.
Do we agree with him? My answer key agrees, so there we go. Now, if you've got $3,000 laying around and you plan to live for 100 more years, you could earn some cash there.
Well,
Now, all of this to say, am I making the point that the longer you leave the money, the more it's going to earn, right? The longer time, the higher interest, the more it's compounded. All those factors go into effect it. Here we went from 4,000 to 60,000.
so basically, I $3,000 put her in the bank for 100 years. When I am 117 years old, I will be delighted to have $60,000.
As I said, as I realized, not exactly the best, we're going to live 100 years longer. Okay, not exactly perfectly realistic, but, I mean, and here's the deal, guys. Obviously, the larger amount of money you put into the bank, the more you're going to earn, right?
So my great grandkids will get to enjoy my small
There you go.
investment.
Okay. We all figured our calculators out, yes?
Yep.
Okay, because you've got to ask, whether it be now or later. Okay, we're going to talk about another interest formula. Okay, so the compound interest formula is the one that traditionally falls under our traditional exponential model. Okay, this one also uses exponents, but it's a slightly different model. And this is our continuous compound interest model. When we talk about continuous, we're talking about this interest is continuously compounding. It is compounding over and over and over in as often as possible. And with that in mind, then, we can't really use our compound interest formula because we don't have an end value of how often it's accumulating, okay? But this compound, or the continuous formula, uses a formula with, and we're going to talk about today, the natural base E. We're going to talk about the number E to calculate and add back accumulated interest at the smallest possible intervals. So it's going to keep accumulating interest over and over and over. Maybe it's every hour, maybe it's every minute, maybe, whatever their smallest possible interval is there. Okay, so your formula. It's actually an easier formula than the last one, if you ask me, because I definitely can just plug this into my calculator all at once. A being the value of the account after T years again, equals P times E to the RT. P is your what? What was P last time?
The initial principal invested.
Okay, it's your principal value, the initial money valued or invested. E is a number. And we're going to talk about that here in a moment when we get to the calculator. But E is a number. It's called the natural number or natural base. R is still your interest rate, written as a decimal. A is still the value of the account after T years. Okay? So, let's set up example A, and then we'll talk about how to use the calculator. Regina invests $12,600 in an account that earns 3.2 annual interest, compounded continuously. What is the value of the account after 12 years? What do you see right here, guys? Continuously. So when you see it's compounded continuously, you have to know, okay, what formula am I going to use? You're using that formula right there. Okay? Automatically, I know I'm going to be using A equals PE to the RT. Now, what information do we have? P is 12,600. That's my principal. What else do we know? What is R this time?
0.32.
Yeah. You move that decimal 2 left, 0.032. Yes, you need to keep the 32 in there, not just the 3. Continuously tells me what formula to use. It says, oh, hey, compounded continuously, we're going to use this formula. What is the value of the count after 12 years? 12 is my T.
Time.
Okay, we're going to fill this in. A is the amount, the total amount we're going to have with the original money plus interest. So realize that when we talk about A, it's your total amount in the account, so the original plus interest. P, my principal here is 12,600 times E. We just write E as E. It's a number. As I said, I'm going to talk about it here in a moment. We're going to talk about where you find on your calculator. E raised to the RT. So that is going to be the 0.032 times 12. Now, one thing you could clean up if you want. Can you go ahead and do 0.032 times 12?
Yeah.
You can. What is that value?
0.38.
Okay. Now, trying to think. Have we done this in this class? I'm not sure. We talked about E in this class this year.
Nope.
I think this is the chapter it comes up with.
Yep.
So you have an E button on your calculator. So E, and I'll make sure everyone finds out here in a moment, is the number 2.718 is the approximation you usually hear. Okay. It's a base of a natural log, which I know you guys don't know what natural logs are yet. But here's the deal. E is an irrational number, just like pi. You know how pi is an irrational number, goes on forever, doesn't repeat? So is E. Okay? So, on my calculator, or on these calculators, I have an E to the X button right here above my LN button. And I use that to get E.
I have an E to the X button.
So, if I want to do this, I could go ahead and type in 12,600 times, and do second E to the X, and then I'm raising it to the 0.384. Or you can type the two multiplied numbers in there. Whoops. You should be getting an answer like such.
E button.
Now, I can't tell you where everyone's exponent button is, but, or E button is. Is there somewhere? Yeah, you found yours?
Yup.
Everyone finding theirs then? A lot of you guys have the TI-30X 2S's, so.
I have a question. What? You should have done the again.
Yes, I can.
Oh.
Oh,
Is it
Okay.
18498?
yes, what was your question?
Are the formulas gonna be on the
Haven't thought that far ahead, but yes, I usually provide formulas in this scenario. So here's the deal. Can you do this if you have a formula?
Yes.
Okay, then we're good, right?
I was just more worried about.
Okay, so 18,498 and dollars and 63 cents. Everyone found their E button?
Trenton, find your E button.
I found it.
Okay. As I said, if you're using one of these calculators, E to the X is on the third button down on the left side, and you have to use the second function to get to it. So just second and then that button.
I'd use the second one. What is LN?
Invented.
LN stands for natural log, which we'll learn later in this chapter.
Why is it an LN?
I got no answer there. I would love to give you an answer there, but I have no idea why the abbreviation is such. Okay. If you have tried that, why don't you flip to the back side and try B? I mean, if you need, did everyone need help getting your answer? You guys all got it. Okay. But you've got to tell me if there's a struggle. I'm more than willing to help.
What is the value of
125,000 is what? That is P. 4.75% is a version of R. Going to be 0.0475.
Oh, I got that wrong.
The first time this question asked me what's the value after 15 years, and so 15 is my T. What formula am I using? A equals P e to the RT because it said continuously. You'll have to watch for those words in homework. Does it say continuous or does it say monthly or annually or what does it say? So 125,000 times e to the 0.0475 times 15. And to be honest, guys, you can plug it into your calculator just like this. That's where today is an excellent day for experimenting, right?
That's not 15.
That is a 15. My BenQ did something weird.
Oh, I actually said a lot about Or, sorry, the. Oh my god. Natural law.
Did you get a big number? Well, some big numbers are right.
What?
What was it? $254,885.32.
Yeah, you know.
Now, in the next one, only thing that changes is the time. Okay.
It's huge.
Next one has a huge answer. 125,000 E 0.0475 times 30. Experiment some. You can plug it into your calculator just like that if you want. At least if it's done right. And 519,000?
Yep.
$519,732.23. Now, you don't have to live, Landon, you don't have to live to be 117 this time.
Oh, hey, I got that right.
So,
Actually, yeah.
this is just 30 years.
I thought I was, on a different planet when I got that number.
Okay. We will tomorrow work with, our only other topic in this lesson is using 2 points to find an exponential model, so we will talk about that tomorrow.
Tomorrow.